Hello, I decided to make another building video, and this is about quite unknown ergo keyboard, Pinky4. So I bought this kit from Little Keyboard, littlekeyboards.com. It's quite well packed. So this keyboard, it is not as popular as say Corner or Kyria. But in my opinion, it is very interesting and useful as a transitional keyboard from ortho to ergo layout. Like for instance, if we look to this keyboard, Viterbi from keep.io. So this is 5x7 matrix, which has numerals, and it has extra columns where you can put bracket keys, plus minus keys, to don't move them into layer if you say get used to 60% layout. So this Pinky4, it has a similar layout, just transformed to ergo. So it has numeral, it has middle column, and what is interesting about it, it uses Kailh hot swap sockets, MX sockets in the main area, but in the thumb cluster it can be used either MX hot swap sockets or Kailh choke, low profile. So using Kailh choke in the thumb row, that allows to kind of more ergonomic position of your arm if you put that keyboard on a flat surface on the table, so you don't need to use wrist rest. You may just rest at the table surface and easily access those thumb keys. Also, I personally like what this keyboard has, 4 well-positioned thumb keys. Like homing position here will be like either, yeah, so most likely this way. Yeah, so can easily access all 4 of them, and that's another thumb key here. Okay, so regarding MCUs, this keyboard is designed for Pro Micro or Elite C, wired variant with TRS connector to connect hubs. But I'm gonna build it as Bluetooth version, and I have, like mostly people use Nice Nanos for Bluetooth builds, but here I have a Chinese knockoff of Nice Nano, Pro Micro NRF 52840, and never used it before, so we'll use either this or another option I not decided yet, is to use Blue Micro 840, which this one I solder myself. I will show how to quickly solder surface mount diodes and hot swap sockets. So it comes with hole through diodes as well, but surface mount is always better looking at the end product. Okay, so those for MX. Yeah, and this is Kailh choke switches bottom. Okay, we'll start with diodes. So both sides are identical, just need to do like don't make the same half. So always make sure what you place them symmetrical. So like solder on one side and then we turn it over and connect hot swap sockets for MCUs from other side. So diodes orientation is shown here on cell screen. You look to diode, it has a no, it's probably not visible, but it has a dash on one side, so that should be oriented to the dash in the diode cell screen picture. So what I usually do, I solder one side and then you kind of warm up that solder and move it diode. Yeah, make sure it is parallel, right? And after that you solder other half. So this kind of surface mount soldering is easiest one, and easy can be done just with soldering iron. Well, it also can be done with hot air. I did it sometimes, but for just simple 2 points diodes, that's kind of not necessary. Okay, so now I will just complete the rest of them. For diodes, before you solder the other side, just make sure that they all oriented correctly and lie flat and along the two marks. Because after you solder other half, it's much harder to fix those issues. Okay, that all looks good. So now I just finalize it. Okay, now for hot swap sockets. It is much easier to do than diodes. You don't need to pre-solder one side. because each socket, it has a gap in the ends, so you just need to place them in, on the same side where diodes are. Place them in position and then pre-solder both sides. So those MX hot swap sockets, they comes into main area, and those choke sockets, they comes to thumb cluster area. It is also possible to use MX for thumb cluster, but I prefer choke switches in the bottom row. Again, the same way as with diodes, make sure what one side is soldered correctly and socket lay flat, and after that solder other side. For hot swap sockets, all the problems have lifted pads. This is because of overheat. So to avoid that, invest in soldering iron with temperature control, because ones which don't have them, they tend to overheat greatly. Now I'm going to complete the rest of hot swap sockets. All the diodes and hot swap sockets are soldered. Now let's see how we will mount MCUs. So first of all, need to find out what pins are used for rows and columns, because we will create a profile in ZMK for Pinky4. which not existing. So all the mapping need to be discovered. Luckily, this PCB, it has labels on seal screen for columns and rows, but seems like last one is not marked because it has only 0 to 4 rows, but it's 5 rows, like thumb cluster row is not there, so we need to find out where is it. I suppose it should be just go after row 3, and same about columns. So we have 1 2 3 4 5 6 7 columns, and it is only column 0 to column 5. Yeah, so one is not marked on seal screen. So to find that, this is easy. Okay, so let's see. Rows. Yeah, so this is below row 3, that will be row 4 here. Okay, now for columns. So if row goes to 1 pin of diode, that column should go directly to the leg of switch. Okay, 0, 1, 2, 3, 4, 5, and 6. Yeah, so here it's reversed. Okay, so this is a mapping for LHC. And it should correspond to this nice nano drop-in replacement. So MCU, it goes this way. Yeah. So it will be mounted from opposite side from here. Yeah, but still it goes this way, elements down. That means for right below VCC, this is column 0. So here we mark column 0, 1, 2, 3, 4, 5, 6. Okay. And other side, okay, ground, SDA, SCL, and then row 0. And we have 5 of them. No, rows we have 4. 1, 2, 3, 5, okay. Let's see then. 6. Yeah, total 5, 0 to 4. Okay, so this one. Yeah, so it is mapped pretty straightforward, just one side for rows, other side for columns, all sequentially. Now let's see how MCUs are gonna be mounted electrically. to the PCB. So it is always good idea to use sockets for MCUs. If something goes wrong, then you can disconnect it, replace it, do anything. If you just solder it permanently, then it's really hard to do anything if something goes wrong. So for this build, because I gonna do it Bluetooth, also need to find a place for batteries. And this PCB, this particular PCB is not designed for batteries. So say I will show you how it's gonna look like for USB build. Like typically I use those low profile sockets, which should go on both sides. It's another one. Then MCU is mounted this way, and also there is reset switch here, and there is a cover designed on the top of MCU, and by design it should use 6mm stands. So with those 6mm stands, and the cover, it will look like that. Very little gap between MCU and the cover. Now, there are two ways to place a battery. Like more popular way is to tackle battery under the MCU, but those sockets are too low for that purpose. So what should be used for that kind of mounts is maximum height sockets. Like, see how much higher they are. So in this case, I just show, like, I have this narrow battery can fit under, and we still put MCU on the top. So this way works better if you have nothing above MCU, or if you say have LEDs screens on the top. But I don't have enough of those, and say intermediate like height in between of those two. It's just not enough. It would be enough if MCU is mounted elements up, but elements down, that's just not enough room. Even it's maybe not enough room because of the USB, like if we mount this way, not like USB is most high point. Okay, so what I gonna do instead, because there is a cover on the top, so I will use those low profile, right? And I put battery on the top, like this. So in this case, it can be even not that narrow battery, but wider battery as well. It will work, like bigger capacity. And I gonna replace those 6mm spacers with 8mm will be enough. I measure that, but I don't have 8, I have 9. Later maybe do with 8. Okay, so let's see. say if I change those to 9 mm, okay, now goes MCU, battery, and cover. Cover. Okay, yeah, it all works. Besides that, like, definitely you can just connect battery directly to MCU and say when you want to restart, just do reset, so it will be permanently connected, and just rely on like power saving features of ZMK, right? But I always prefer to add the switch in the circuit. And here, because we have a predefined place for reset, like if not that reset switch, I would just hot glue it down here. But with that cover, what I can do, hot glue it on the top and mount. That's what I plan to do for this build. Let's solder sockets for MCU, and make sure you do that from opposite side of diodes and hot swap sockets. So they gonna be connected to outlined position. That's our row of holes. This is for opposite side. When you solder the row, do two opposite sides first and make sure what it sits flat before proceeding to the middle. because pins are in plastic, you should not overheat socket or the other side will start melting. And make sure what you do not create bridges, because for this particular one you may shut two pins this way. Yeah. So such kind of problem may happen for all designs like that, like Kailh. To solder MCUs to the sockets, the typical approach is to use diode legs. So I have plenty of them. I don't throw them out when solder diodes. So what you need to do is like take diode leg and push it through to the socket. It has a wider opening at the top and narrow passage down. But before doing that, it is good to protect the socket from solder drip down. So for that you can use that painter tape, just narrow strips of them. Okay, so let's see. It's not enough to our side, I have more. And then you don't need to make holes before soldering. Just like place MCU on the top, push diodes through the tape. And also after soldering, I usually don't disconnect, don't remove it, because I mean, it's no harm if it is there, only if later you need to disconnect MCU when you can remove it, but before that it's no reason to do. Okay, so now let's do one side. Yeah, also like diode legs, it cut from one side and has factory end from other side. Prefer to do factory end down. It's usually easier to push through. Yeah, so, and make sure it's went down. So you cannot control how deep is it, but need to make sure what it is not halfway. Yeah, so it's usually like 2 stages. First you just move it through the tape, and then like that first, and then going deeper. Yeah. This MCU has 13 pins on each side, the top ones that's for battery. Unlike typical Elite C or Pro Micro, they have only 12. But that's the same as Nice Nano. Nice Nano has extra 13 for battery connect. I've pushed through all diode legs and now it's time to solder MCUs. Also, I didn't mention, don't try to do it without MCU because it is really hard to put it in place with long diode legs afterwards. Probably you may cut it, but I don't think it's worth that experiments. So here just do opposite edges first, like one corner, and make sure it's settled. Then other corner. And then other side. Because if you start to do them one by one on one side, it's very easy to get into situation when MCU not settled. Okay, yeah, now when corners are done, can complete the rest. And now I need to cut off the leftover of diode legs. Those I typically don't save anymore because they cut from both sides. This is my solution for attaching battery to MCU. So I use that top cover. First I thought to glue battery directly to MCU and switch to that cover, but that's better to put them together, so when you disconnect the cover, it will not hang on different parts. So battery connected to switch, and then wire goes underneath of MCU and connect to battery pins. So now I just need to put screws that. It's semi-transparent. It's okay. Okay, so this is like that, and turning on this and turning off. PCBs are completed with sockets, diodes, and MCU and batteries, all the harness needed for Bluetooth. I also tested that master and slave halves are replying and working. So what needs to be done now? Just to add switches and cases, and we are done. So those switches will go into bottom and case.